Imagine a system that never sleeps, a tireless team of AI agents working around the clock to analyze, rewrite, and optimize your machine learning code. We are going to build exactly that. This setup is based on Andrej Karpathy's AutoResearch project, which takes a simple ManorGPT training script and relentlessly improves it. But instead of relying on expensive proprietary models, we will go this using strictly open source tools. This chart plots our experiments against the bits per byte metric. Over the course of 600 trials, the agent identifies and stacks minor code improvements, steadily driving the error weight down to the lowest point of the run. This flowchart outlines how we divide the work. Instead of asking one massive AI to do everything, we split the cognitive load across specific roles. It starts with a researcher agent finding papers, feeding ideas to a planner agent. Worker agents then patch and run the code, while a reporter collects results, establishing a continuous feedback loop. By distributing these tasks across specialized open-source models, a single developer can execute high-level AI research right from their local machine. To set this up, you need 4 things: a configured Python environment, the OpenCode harness installed locally, an active Hugging Face API key, and our specific tutorial repository cloned to your computer. Before launching the system, there are 2 authentication steps where setups usually break down. First, your local terminal must be connected to the cloud. Open your terminal and run hfauth login. This command directly links your local machine to Hugging Face. Next, the OpenCode harness itself requires its own separate permission to access the language models. Run OpenCode auth login. When prompted, select Hugging Face as your model provider and paste in your API key to complete the bridge. Without this precise dual authentication setup, your local agents are completely cut off. They won't be able to access the open source models or cloud storage required to function. With the connection secure, navigate into your cloned repository folder and launch the OpenCode UI. By default, OpenCode operates as a standard coding assistant, acting as a basic build or plan agent. Running the workflow in this state will fail. We have to manually reconfigure it. Go to the Agents menu, click Switch Agent, and select the Agent Auto Load option. This profile points the software to the customized Markdown templates hidden inside the repository we cloned. This agent profile is what enables the multi-agent logic, partitioning the generic interface into the 4 distinct research roles we defined earlier. Now we initialize the system. Paste our master execution prompt directly into the OpenCode chat. This diagram illustrates how the system manages resources. By pointing the agents to the Hugging Face cache, we route all their data into a single shared bucket in the cloud. Establishing this shared bucket prevents concurrent jobs from redundantly uploading and downloading heavy assets every time a new task begins. Next, the prompt commands the system to spin up 5 worker jobs simultaneously for maximum throughput. The most critical guardrail we include is an explicit command: do not stop until you have a full pass. Open source models natively struggle with long-running tasks. Without aggressive prompting, they tend to halt prematurely. By carefully engineering this single master prompt, we bypass those inherent limitations and force the models to execute continuously in parallel. Once you hit enter, monitor the OpenCode trace to verify that the main thread is successfully spinning up the subagents. The system first hands tasks to the planner agent, which reads the repository templates to generate fresh experiment hypotheses, like adjusting the learning rate. After the workers execute the code, the system shifts focus to the reviewer agent to evaluate the raw data from those experiments. The reviewer's logic is strict. It logs successful runs, where a change improved the code, and identifies failed runs, where the training efficiency decreased. It ignores the failures entirely, taking only the successful modifications and feeding them into the planner's queue for the next cycle. This automated closed-loop cycle of hypothesizing, testing, and reviewing completely removes human fatigue and bias from the code optimization process. With 5 simultaneous agent jobs running, the standard terminal trace becomes impossible to read. We have to monitor the system at a macro level. For that, we use Tracheo, an open-source dashboard specifically designed for visualizing live machine learning metrics. This is the best delta versus master graph. It tracks the AI's exact improvements over the original script by actively plotting new data points as each job completes. You should also check the Hugging Face hub to verify your active worker jobs, which the system automatically categorizes using specific hypothesis tags. At this stage, you have a fully autonomous AI team continuously generating ideas, writing code, running experiments, and reporting data. To set this up yourself, check the description for the repository link, the companion blog post, and the OpenCode software. Using this local multi-agent setup allows a single developer to run the kind of high-volume iterative experimentation, but usually requires a full research team, essentially turning a standard laptop into a 24/7 automated laboratory.